You probably know by now why I started with the y-axis, because it was the simplest one. For the C, basically I have the option to go left or right. The original one is mounted on the left, but the problem that you have to somehow work around this clamp, which is clamping the axis. And on the other side you saw the Euchner end stop. It's an insanely complicated system that I delivered with this machine. The machine was able to do some half or fully automated cycles, like moving the x-axis and then lowering or raising the table by itself, and the end stop somehow stopped it and moved in the other direction. That's why there are all these stops there. Honestly, I have never used this function. I'm not even sure if it's working, but in the back there are tons of cards and old electronics that is responsible for the movement there. But it's not really viable. I think it's basically built for doing large production cycles. So you just turn the end stops in, and then the machine is exactly stopping at the point you want, and it's going up. You can move the part, put no other one in, or it can do a large milling operation starting from the top and milling it all down the way to the bottom. But in my case, I only do most of the time single operations, just one or two products or projects. So that was never really, to me, it was never really worth the effort to go into how to actually program the thing and fine-tuning all the end stops to exactly get him to stop where you want. So I basically just ignore this function for now. You can switch it off and just use it the way I showed you. So just manually move the X and Z axis with the lever without having the automatic engage. I think. All right, change of plans. As you can see, we are now on the right side of the machine, and I had some trouble getting the other clamp, the holder that is the lever and that is fixating the table loose, and it's really stuck in good there. And on the other hand, that also would be very difficult to actually make the bracket, because I think they're originally using a complete part where the bracket is attached. I mean, it would be possible, but I just took a look at some other footage, and I came up with an idea that I can mount it like this. Basically, I just add spacers on the top and bottom, and then I already have a nice perpendicular surface where I can basically orient the scale. And just going to the head here, and I opened up the Euchner end stops, and it's just a chunky piece of casted aluminium. So I have no trouble drilling 2 or 3 holes here, and then make like an L-shaped or some kind of attachment that just goes like that, and the head is on this side. The advantage would be that the scale is completely protected, because the open side is going first in the back, and as I said, I have a nice aligned surface here, so centering the scale also is not a problem. And for now, I think I'm going with this solution. So I found this offcut, and now basically I'm milling 2 pieces out of that, cutting it first, then milling 2 pieces out of it, and it has the same dimension as the scale. So I'm mounting one here and one at the top. The top one is probably going to be shorter, and then I have a nice surface that I can mount the scale to. I milled the 2 adapter plates off camera to size. They're a little under 34 millimeters, so that they will fit behind the scale and you will not be able to see them. Just have to deburr them, and then prepare them for drilling and tapping. What I did off camera was milling these little distance blocks. It's drill and tapped for M5 right here, and through hole for M4 with a recess, so that I can have 2 M4 screws, and that's where I am mounted to the machine, and that one is for the scale. So basically on the machine it will be mounted like that, and that's the shorter one is on the upper mounting position, because there is not enough left on the machine. I almost got a heart attack when measuring the scale because it stopped somewhere right here, but then quickly I realized that I used the wrong scale for measuring. Now that is the right length and it looks good. You can see here behind is a bracket that I milled earlier, and it's already mounted to the machine, and that's basically the M5 thread where the scale is threaded on, and then all the way down there I will install the second one here. And the head is basically mounted somewhere to the end stop and moving along with the table then. And here is one point that I mentioned earlier. Now the end stop of the machine triggered, so with the automatic feed I can't go further down, but sure enough, if I use the hand wheel, there are several centimeters left of traveled space going further down. If I wouldn't have had accounted for that, now my scale would be broken because I just pushed it down on the end. So really keep that in mind, even if there's an actual stop that you sometimes can override it, or you can simply move the stop by moving the nut. So just a quick update. Unfortunately, I made a mistake. The scale was too far on the left. When I tried to mount the second distance block, I realized that it's hitting the Euchner end stop with around 2 millimeters. So it's here on this edge. So what I did was I just moved the blocks a little bit to the right. I mean, there goes my alignment surface here. That's a pity, but there was not much I could do. The holes are still covered, so unfortunately I had to drill 2 new holes, but they are covered with the blocks, so at least no one can see what I did there. I leveled it down, tried to stay as parallel to the end stop, end stops as possible, and now I'm gonna drill the 2 holes on the bottom, and then I can mount the scale. And here you can finally see both brackets installed, ready to mount the scales. Here you can see the scale mounted. As I said, I'm going to indicate a min at the end when I'm ready with all the brackets. Just to give you a rough idea. Now what I need to do is find some kind of solution to mount the head of the scale to the end stop. Basically something like that here. I'm not sure yet. I'm gonna figure that out. I dug through the cutoff pile and I found some parts that are quite nice fit for the angle. You obviously just could mill them out of a full material, or maybe you could even get away with the 3D print, but that's what I had, and now I'm gonna transfer the hole pattern from the head. I just made a rough template, measured it, and just had a sanity check to check if it's actually aligning. Then I'm drilling the holes here. This is for mounting the head on the side, and I will show you the next step over at the machine again. Here you can see the holes that I just drilled. The head is threaded here with 4 M4 threads, so that's how I'm gonna mount it from the back side. You can see there are plenty of mounting options. Here's for M5 and M4 through hole. So basically you have a lot of options to mount the head depending on your specific situation. As you can see, sometimes it's a tedious project, so if you have the option to get a fitting set like brackets and angle blades for your machine, especially if you buy a new or smaller machine, they sometimes offer that. You might consider that. I mean, if you like to mill and drill these brackets, and if that's what you're into, then it's a very nice job. But if you just want to get started with your milling machine, then maybe it's a better option to just buy the brackets and simply drill and tap the holes on the machine. Here you can see the bracket in place. I temporarily screwed the transportation fix, the right one, to the reading head, so that I can, it's easier for me to measure how much space I actually need here for this spacer, because now the head has the right distance regarding to the scale, and all I need to do is find some spacer for here, and then I'm gonna drill and tap it from this side to the head of this. This is very solid cast aluminum, as I said before, so it's holding up very well. I can drill and tap it without any problems. I prepared a bracket for the holder, and now I'm gonna bring in it to a size on the belt grinder. I wanna give it a little bit nicer shape, that it's not like that bulky, and have the edges rounded and give some radii here. I can't film here, so we're gonna show you. Gonna show you the final result later. So now we're back from the belt grinder. I just basically freehanded the radii here to make it look a little nicer. Started with 60 and 80 grit and then polished it a little bit with 400. I think it came out quite nice. So I'm just gonna dry fit it here, and then I'm gonna puncture the holes and drill and tap them in the end stop. Here you can see one screw already mounted, and now I measured the second one and marked it here to drill. I took my time here to really align it, and I didn't want to damage the case here. But I realized once I mounted it that it's bended slightly, so I have to mill that one down approximately 1 millimeter, so that the scale head is coming further to the scale. Because I had a transportation protection mounted, the mount had somehow pressed the scale, the head against the scale, and now that it's free floating, I see that the gap is a little bit too much. Or maybe I bended the angle a little bit while belt grinding, I don't know. But the easiest way in my case is just take this thing off and mill 1 millimeter away in diameter here. Here you can see the end stop, and that's other two holes that I drilled and tapped. It's very clunky. Casted aluminium, so it's no problem. And there's also some space left here, so I will never interfere with the actual wiring. But obviously I have to take care of the screw length, so I just measure them correctly, that I will only, I will still be, that nothing sticks out in the back here into the wiring. Now here is the final installation. The last screw is basically bolting on the distance block, and the other two are screwed into the case of the end stop. Again, I'm gonna finish up the adjustment at the end, but I call it good for now. What I'm also planning to do is in this case, to mount some relief here. For example, just drill one hole, and there's some clamps included, and clamp the cable here, so that I have some, if something will happen, I'm not going to rip the cable off, so that it has some wriggle room and to run up and down here. But that's what I'm going to do in the end. So hello again. Now we're here back for the X-axis, our last installation on the machine. I opted here for asymmetrical installation. I moved the scale as far left as I could, because I wanted to have a level surface here to mount an angle like that for the head. So in this case I can use the full travel and still have some space here for the head, so that I will not crash into the machine. Basically the same, I drilled and tapped the holes. Now I roughly aligned it and leveled it. I will show you from the other side. Here you can see, first I checked if the machine is level, then I leveled the scale roughly, and I will indicate it in at the end. But that's quite good. As I said, the thing is not terribly accurate, but I'm at 0, so that's fine for now. I can just finish the installation of the angle mount for the head, and at the end I will indicate all the scales into perfect dimensions. The adapter plate I'm working on for the head has to be milled down a little bit, so I thought I took the chance to show you the fly cutter I built in one of my previous videos in action. What I now discovered is that my head is slightly out of trim. I don't know how that could happen, but there's nothing I can fix it because it's not. I'm not able to tilt it in this direction, so I don't know. Maybe I have to check it, but it's ever so slightly. So you will see that actually that it's if the cutter is passing, you will see the next point that it's moving the recut when the head is out of trim again over the surface. So just take a look out for that. I'm taking 2/10 millimeter of a cut and feed radius 300 millimeters per minute. This is too fast to get a perfect surface finish, but I want to get it down to 1 millimeter fast, and then do the last part with 200 millimeter per minute. Here you can see the head making the recut just ever so slightly. I think you can hear it. Finish really is spectacular. It's very good. No words whatsoever. You can see it's basically a mirror. I'm quite happy with that. That's usable. Here you can see the stop we just fly cutted. Basically, it's like a sort of adapter blade that uses the angle points here to be drilled and tapped. I just bolt it down like this, and then I'm using a piece of 2020 to align the head perfectly. So I can use the bolt hole from this side, and then I still have some wiggle room to align the head here in case it should be out of alignment. First I thought I could bolt the head from below. That would be possible, but it's very hard to tilt it afterwards and to bring it in the right angle. So this solution makes it much easier for me, and because I can basically access the bolts from the top here and don't have to go from the bottom. Here you can see the adapter plate already test fitted to the machine. Now I'm gonna mark the 3 holes and then drill and tap them in the machine. This is the block, I also built that one off camera. This here is the distance for the head, so that one goes right there. And that one are the alignment screws that I will also mark on the blade once it's installed. Here you can see the final mounting bracket. I drill and tapped M5 for the head, and there is M5 as well, so it's just gonna... I always drill the holes a little bit oversized so I can align it better here, because I have to drill all the holes in the machine by hand, and sometimes they move a little bit on you, so it just gives me a little bit of space to align it afterwards perfectly. Here you can see the final installation. I focused on the gap. It looks excessive on the camera, but it's around 1.5–2 millimeters. Basically, what the transportation holder was as well. I just mounted the bracket here and all that, and the head is finally mounted in the machine. Now, what I'm going to do is I finalize the adjustment of the X scale in order to get the height right. I eyeballed it to be around 1.5 millimeter. Please make sure that there is an actual gap between the head and the scale, otherwise it will rub on metal the whole time. And also make sure that the gap is not too wide, otherwise the head it's kind of hanging in the scale and then it's scratching on the other side, so you will hear some scratching sound. That's not good. So if you hear the sound, please stop immediately and readjust the position of the head, otherwise you might risk damaging the scales. Here you can see now I'm turning, the scale is moving, head is stationary, and you can't hear anything, any gliding, any binding of the head against the scale. That's very important, so you can hear just the axis moving. What was very neat, I am able to feed the cable through the frame here, so there is a hole. Now that actually concludes the mounting of the scales. Now what I'm going to do is I'm gonna indicate them in, and after that I will mount some, drill some holes and mount some cable reliefs here, strain reliefs somewhere on the machine, so that I'm not going to accidentally rip off the cable from the head. Screw also arrived finally, so this gives you a sense what I designed from the arm. I can tilt it forward and back, and I still have the option to loosen that one, and then I can tilt this whole installation and shorten the arm here, so I have around 10 centimeters travel in Y as well if I need to. I wasn't quite sure with the hand wheel, but I think it looks quite fine like this. Let it down like that, and then from the front you can see like this. Basically I'll be tilted and I'm still clear and away from the quill if I decide to need it and use it here. And here's our result. All axes are moving and the scale is counting them correctly. One thing I did notice though is the display of of the DRO itself is very hard to read. I think it's better to see on camera, but in real life the numbers that are not illuminated are kind of driving me crazy, because I always can see that they are not on, but they're blocking the display somehow. I'm just looking through the camera now, and you can't see it on camera. It's the picture on camera is way clearer, but for me it's really hard to read the numbers, because you all think that it's on and a little bit glowing afterwards in real life. So that is really a big disappointment comparing to the Sino DRO. Just gonna bring you over to the other machine and show you the Sino in comparison. So what I really want to show you is the issue I had with the display. Now I think it's the lighting in my shop here, because I have very bright LEDs on the ceiling. Now I switched everything off. It's just the light in the other room, and you can see the display is crystal clear and very crisp to read. So it's not really an issue with the display itself. I think it's just that my lighting is lighting on the I have some fluctuation on the display, and it's some weird angle, so it's hard for me to read. Now when it's dark, I mean, obviously I can't work like that, but you can see that the display itself is working quite well. Unfortunately, okay, what I'm trying to do now is give you a sense of repeatability. So I have an indicator here on the y-axis, and it's 2 revolutions in, and now I zeroed out the y-axis to 0. Moving the y-axis forward 50 millimeter. All right, taking on the backlash. Now going back again and trying to hit the indicator at 2 revolutions, and we will see what kind of difference there is in the scale. Try to hit on point, and you can see I'm 0.004 off. It's not even. It's for me even hard to see. I'm actually hitting 0 from here. So 0.004 off, I would call it good enough here. I think it's probably in this case it's the indicator moving it here and there, but I'm quite happy with this result. So I think, as I said before, to me the scales are pretty accurate. That's at least what I gathered from testing. I didn't even fine tune it, so basically what you saw here was just using them as I have installed, just eyeballed, slightly leveled them, but I haven't even indicated them finally in. Just wanted to see what's what now, and I'm very happy with this result. Alright, now you can see the display with switched on lighting in the shop. As I said, it's very, very bright LED light. You can see that it's much harder to read now. But that's probably an issue here for me. Maybe if you use different lighting, you won't even experience it. So in the end, I would say this set is definitely worth the money. What I would do maybe if I buy a new one for another machine, I would maybe just buy the scales from them and either ask them if they offer a better display or a different kind of display, or just check out before what kind of display I can use. So I would go with it, like let's say cheaper scales, because as I experienced, the quality is very good, so I wouldn't mind using them on a different machine. But for me in here, I would probably like to get a different display. Alright, that's it from me. I hope it was helpful for you, how to install the scales, and to see you in the next video. Thank you.